Alright, so what we're going to do today is continue with the trigonometry topic. So the topic we're going to do is something called a given one trigonometric function, find another. Alright, so what does that mean? What we need to use is the idea about the all station to central to work out what happens if I have one trig functions and we need to find the other trig functions. So for example, if it's given like sine theta is equal to 4/7, and then the question asks you to find cos theta. Alright, how do we do this question here? There's a couple of ways you can do this question. At this stage, I think the best way to do it is thinking about a right angle triangle, and then you start to think about which quadrant in the angles theta lines. So have a look at this question here. So we've got sine theta equals to 4/7. If I try to draw a right angle triangle, that's angle theta. Sine theta 4/7, which means 4 and 7 here. And then what you have to do is to work out the sides adjacent, or I guess this is called adjacent side. Adjacent side. So that's 49 minus 16, and that's 33. So it's going to be a square root of 33. So now you get a square root of 33. So you've got a triangle like this now. So we've got sine theta equal to 4/7, and from this ratio, I've got the right angle triangle opposite of a hypotenuse is equal to 4/7, and that resulting the adjacent side equal to square root of 33. So from here, you should be able to work out what is cosine theta, because if you look at that triangle, cosine theta is equal to adjacent over hypotenuse, which is equal to square root of 33 over 7. Alright, so it looks like that's the answer, right? It looks like that's it, that's the answer, it looks pretty good, everything is right. But is this the only answer here? So that's what we need to think about. Is this the only answer? Can we have more than one answer for a question like this? Then we start to think about the quadrant. Where is the angle theta? Right, where is the angle theta? Alright, so starting from a sine theta equal to 4/7. Sine theta is a positive number. So if we start to think about the all station to central, if sine theta is positive number, so for example, it's positive, right? That means the possibilities for a theta to be is the first quadrant and the second quadrant. The first and the second. Everything is positive, sine is positive in the second quadrant. And then we have no idea where is angle theta. It could be in the first quadrant, could be in the second quadrant. So what we need to think about is it's two options, right? And in that case, theta is actually between 0 and 180 degrees. Or actually, without equal something. So between 0 and 180 degrees. So it could be in the first quadrant or in the second quadrant. Then I'll start to look at this one here. That is a positive answer when theta is in the first quadrant, because cosine is the same, is positive in the first quadrant. However, we can also have cosine theta equals to minus square root of 33/7 for theta that's in the second quadrant. So that means we have two solutions. One is positive, one is negative. Well, we don't know where is the exact location of the angle theta here. All right, so that's the first example where we don't know about where's angle theta. How do we find out the ratio of cosine theta here? We use a triangle. We use Pythagoras to work out the other side, and then we try to decide, using the correct ratio. So kotoa, we can work out what is the ratio for cosine theta. But we just need to be very careful about a positive answer here and a negative answer there, because the location of theta is in the first and second quadrant. All right, so let's have a look at another question here. So that's example 1. Right, this is an example 1, and let's have a look at another example where we know the exact location of angle theta and how are we going to do the question. All right, let's move on. Right, so let's have a look at example 2. If tangent theta is equal to half, let's just do half, and sine theta is less than 0. All right, if that's the condition we have, right, tan theta is equal to half, and to tell you that, sine theta is less than 0, it's a negative number. You don't really know what sine theta equals to right now, but you know it's a negative number. And that question asks you to find cosine theta. All right, what is the cosine theta equals to? All right, so we'll start with the question with the normal triangle, right? So like a right angle triangle with angle theta here. And that's a right angle. Now, according to this rule here, so because tangent theta is equal to half, that's 1 over 2. That becomes a square root of 5 after you use Pythagoras. All right, so once you finish that, and then you start to look at, I'm pretty confident now I can use the circle tool to work out what's cosine theta here. But then you start to think about, where is the angle? Where's the angle? Right, let's draw a quadrant or station to central. So firstly, tangent is positive. All right, tangent is positive in the first and third quadrant. However, sine theta is negative. Now, sine is negative in the third quadrant and the fourth quadrant. So therefore, the common quadrant we have here is the third quadrant. All right, so that tells you that cosine theta must be a negative number because it's in the fourth quadrant. All right, theta is in the fourth quadrant. Theta is in the third quadrant. All right, so therefore the cosine theta is equal to negative 2 over square root of 5. Now you can rationalize the denominator or you can leave the answer like this. If you do rationalize the denominator, that becomes negative 2 root 5 over 5. So you've got another trig ratio. All right, so that's an example 2. So this is where you know where's the location of, exact location of angle theta here. All right, so what I'm going to do right now is we're going to move on to an example 3 where the question becomes slightly harder than the previous 2 questions. We'll start to introduce some negative numbers. When I'll give you the ratio here, I can give you something in terms of negative numbers there. And then I can ask you to find out some other uncommon trig ratios. All right, let's move on. All right, let's put equation example 3 here. So if cosine theta is equal to negative 2 over 5, right? Negative 2 over 5. And sine theta, let's say sine theta is positive, right? Greater than 0. Now the question says find set. No, probably not set. Let's do cotangent. Find cotangent theta, or calculate cotangent theta. All right, so let's have a look at the given condition. We have cosine theta is equal to negative 2 over 5, and sine theta is greater than 0. Find cotangent theta. All right, I'll give you some time to think about how to do this question here, all right, before I start to talk about it. All right, so how do we do this one? We have cos theta is equal to negative 2 over 5, right? Based on this, what we can do is to create a right angle triangle. Now, you don't need to worry about that negative because negative in the front just tells you that which quadrant of the angle. So we'll just say this is theta here, and according to the ratio, we'll just look at the magnitude of the ratio. That'll be 2 and 5 here. And then the opposite side using Pythagoras, that will be 25 minus 4, and that will be square root of 21. All right, so we've got everything we need. Now we need to decide the quadrant or station to central. What is the quadrant? Cosine is negative. All right, so that's positive here. That's positive here for cosine, first and fourth quadrant. So cos is negative in the second and the third quadrant. Then based on this information, sine is positive in the first and second quadrant. Therefore, that must be the quadrant here because sine is positive. All right, based on these 2 information, we end up with the second quadrant. All right, so the angle theta is in the second quadrant. That means we can start to find the answers, right? So start to calculate what's called, cotangent theta. So cotangent theta is equal to 1 over tangent theta, which is equal to 1 over. Now, it's in the second quadrant. And tangent is negative in the second quadrant. All right, so tan theta. All right, so let's start with tan theta here. Based on this triangle, that becomes opposite over hypotenuse. Sorry, opposite over adjacent. And that becomes square root of 21 over 2. Now, rearrange this expression, you get negative 2 over root 21. And that is the only answer you have. All right, you can't have any other answers. And that is the only answer, and that becomes the answer of the question. All right, cotangent theta is equal to negative 2 over square root of 21. All right, so that's it. So that's the exercise. I would like to teach this lesson here. It's pretty straightforward. All you need to do is remember that you are going to get probably given 1 or 2 different conditions, and then you're going to use the conditions here to either draw a triangle, a right angle triangle, and then you're going to create a quadrant diagram here to decide which angle, where's the location of the angle. And once you finish that, you should be able to work out the exact location of the angle, and then use the SOHCAHTOA to decide the final answer here. And then whether it's positive or negative depends on the location of the angle, and depends on how many information they give it to you. If they don't tell you anything about it, the location of angle theta, then you might end up with 2 answers. Could be positive or negative. All right, that's all for this lesson here. Thank you, everyone. All right, I'll see you next time.